Today my topic is open source software supply chain recommendation based on heterogeneous information network. And with the rapid development of the open source ecosystem and the popularity of GitHub, more and more developers are choosing to build open source projects based on GitHub platform in an open, share, and collaborative software development model. According to the 2021 annual report published by GitHub, there are over 610 million new developers and 61 million newly created repos. Under the main purpose of open source software supply chain recommendation is to recommend open source projects of interest to developers and to establish more connection between the vast number of developers and the open source project. The framework we propose consists of 4 stages. The first one is the data preprocessing. And the data source comes from the GitHub Archive project. We designed the automated data integration program to manage the massive GitHub public event stream data. And the second one is authoring construction. We give the definition of the authoring and the schema. And then we conduct the authoring-based embedding and the personalized recommendation. And I will take 2 minutes to briefly describe how we are performing GitHub behavior log data analysis. The data we use is powered by an open source project called OpenDigger. This is an open source project created by XLab, and the number of complete logs in 2020 was 860 million, and in 2021, it topped 1 billion. There are a lot of interesting things that can be analyzed from these behavior logs, such as who made what contribution, when, through what collaboration, and with what impact. We measure, model, and analyze project developers and other projects to derive easy to understand metrics such as activity and influence. And the rational graph data is very useful mathematical tool similar to PageRank. And back to the point, in order to accurately model the weighted heterogeneous open source information network in the project recommendation scenario, we comport the open source collaborative development process based on the GitHub platform and analyze the GitHub public event stream data. And finally, we select 4 types of nodes and 9 types of link relationship, and we abstract the attribute value on the relationship. This figure shows the authoring schema, which contains 4 types of objects and the various relationship between these objects. And based on the above network schema, we propose the authoring generation algorithm. The algorithm consists of 2 stages. In the first stage, for each repo in the given set of open source projects, the developers and the issues and the pull requests associated with the repo are aggregated and filtered from the GitHub event stream data. And then these nodes to the network, add these nodes to the network instance. For each developer, the second stage filters the developers of interest and the associated issues and pull requests, and then add them to the network instance. After that, we conduct authoring-based embedding, including a random walk strategy based on unweighted meta paths and weighted meta paths. And we maximize the conditional probability of the local structure of the network according to the optimization objective function, and use the embedding representation under multiple meta paths. And then finally, we integrate the personalized nonlinear fusion function into a matrix factorization model for GitHub project recommendation. And here is our experiment, and we select 360 open source projects from CNCF to build the experimental data set. And we use this from metrics to measure the performance of our method. Here is the result. And in order to verify the effectiveness of the method, the following method was chosen as the baseline method for the experimentation, and the result shows that our method performs better than other traditional recommendation models. And in order to measure the effectiveness of our constructed meta paths, we compare the performance of the recommendation method and the different meta paths through several comparison experience of different meta paths. And the result shows that the metrics of the model gradually increase as the meta paths are added. And then finally, we conduct and we measure the performance of different graph representation learning method, and the result shows that our method is better than other methods. Yeah, that's all. And I'm from S-Lab. Our lab is an open group for open source research and innovation. It's connected by experts, scholars, and engineers from university, startups, and IT companies at home and abroad, focusing on the open innovation of the open source software industry. Yeah, that's all. Thank you.